Hello. Welcome, everybody. My name is Shivaram Mysore, as she mentioned. I'm actually a technical strategist at Infoblox in the office of CTO. And today we are going to talk about software-defined networks and white boxes, network white boxes. So when people talk about software-defined networks, or SDN in short, they could mean a whole range of things. So let me set the stage with what exactly we mean by software-defined networks. In one scenario, networks are aware of applications. For example, the network may have prioritization for Hadoop-style traffic. That means it knows as to the traffic that is coming in is actually Hadoop-style traffic, and hence it can do certain things. In another scenario, networks are programmable. That means one could program or insert specific flows into the networking switching equipment, predominantly which is programmable, okay, to either filter traffic or allow specific traffic from specific ports or deny traffic. So those are the two common scenarios that we would like to consider when we talk about SDN. One of the underlying common themes for an SDN-based network is that it is predominantly based on Ethernet, and that is universally available on almost all of the networking hardware. The concept of network white box is used when networking software is actually run on these kinds of commoditized Ethernet-based hardware without using any specific hardware acceleration. So there could be kernel mode libraries and other kinds of software enhancements, but there is no hardware-specific ASICs and that kind of stuff. And flowforwarding.org is actually a community based on promoting OpenFlow-based SDN on network white boxes. So let's look at what this community is all about. We are focused on implementing and promoting Open Network Foundation standards. All implementations are released under Apache 2 license, which is extremely commercial friendly. And the community itself is actually supported by various industry leaders who have contributed enormously to promoting this OpenFlow-based SDN. Link is a OpenFlow-based capable switch, which we are going to talk about in a couple of slides, which supports all the latest OpenFlow standards, namely 1.3.1, 1.2, and also the OFConfig 1.1. And it can work with any available and standards conformant OpenFlow controller. Namely, we have tested it with Ryu, Ixias controller, and so on. So on what platform does Link run on? Link basically runs on a wide range of hardware platforms, from the smallest of the small Raspberry Pis, which are like $35. Okay, it's an ARM-based processor. And it can run on various Intel Atom to Intel Seacliff Trail platforms, and even the Tylera platform, which has around 72 cores on its CPU. So it can run on a whole range of platforms. And in the Raspberry Pi case, because it has only one Ethernet, there is also a USB port. You can actually plug in a Wi-Fi adapter to it, which will make it into an OpenFlow wireless access point. So hence, an OpenFlow switch. So it is said that a picture is worth more than 1,000 words. So what I really wanted to talk to you about is how you could actually use OpenFlow today and in your existing corporate networks, and what are some of the things that you could do with it. And the next set of slides are going to walk you through a whole range of deployment scenarios that you could actually use today. So the first and foremost is the question that we get commonly asked is, how can I deploy OpenFlow in my corporate network today? So we use a system or a technology called overlay networking. That means one network running on one kind of protocol network running on another protocol network. So what you see here is the top of the rack switch, okay, and to which you have DNS servers and everything connected, and you could probably have an OpenFlow controller also connected to it. The IP addresses mentioned here, I mean, you could actually deploy such a network. I mean, these are certain things that we have done it constantly and many times so that it is easy for you to replicate the same in your network. And we deploy a link OpenFlow switch into this network with this as the management port. And this Linux Blade server could be used as a whole bunch of Linux clients, okay, or any kind of clients, OpenFlow clients, because they are connected to an OpenFlow switch. So with this methodology, you could actually run OpenFlow-based network in an existing corporate network. Now, as we mentioned before, the very purpose of using OpenFlow-based SDN is that we need an ability to program the network. Whenever we try to do a proof of concept deployment, we don't want to write that much code. We want to say, can we use a REST API so that we can use some commonly available tools so that I can push certain flows onto the network. And REST is one of them. Here, what we have done is that we have taken the link OpenFlow capable switch, which is running an instance of the OpenFlow switch, and to which a root controller is actually used to connect to the switch so that it can be programmed. Root, which is an open source controller that is available, also supports a REST service, and a programmer has the ability to send commands via curl or other kinds of mechanisms to root so that they can actually program the flows. You could actually add a flow, delete a flow, and do certain things like that, get flow information, and so on. So in terms of, we took the programming to a next step. We said, okay, now that we know as to how to program the network, OpenFlow network. So let's look at how can we build a dynamic firewall with ThreatStop-based events. So ThreatStop is a service that is available on the internet. They monitor in real time information about blacklisted domain names and IP addresses. So if a particular domain name or an IP address is hacked or infected, they get a notification and they publish this information as a service to various subscribers. And what we did is we wrote a program to consume these events so that we can dynamically program the OpenFlow switches with corresponding flows to either allow or deny a traffic to those IP addresses. So if a particular IP or a domain name has been infected, we would actually block access to that IP or domain name. If a particular IP or a domain name has been moved from that blacklisted to saying, okay, everything is now fixed, okay, you can now continue to access the domain name, then we update the flow entry to actually say, hey, this is now going to be good, so you can actually access it, or we basically delete that blacklisted flow entry. So why is this so important? Now, if you have an OpenFlow network or a programmable network, now if you say to this OpenFlow network, I connect all the BYOD devices, that's bring your own device to the network, and if I do all of that stuff, now these devices already have connecting to a switch which is up to date in terms of firewall rules. And that's a very important feature for a network, for an enterprise network, to have so that it can secure the devices and the network. So we started looking at programming, and we said, okay, we got excited. We said, oh, we got firewall working. Now, we said, can we do something for Hadoop? Because people always complain that it takes a lot of time for us to process a Hadoop traffic, and there are all kinds of things. I have to buy expensive hardware. So we looked at saying, okay, how can we take the switch that is connected to the Hadoop cluster and replace it with an OpenFlow switch and see what would happen. So we did this experiment 18 months ago when we first developed Link, and we said, what value can we provide to a Hadoop network? Can we program something here so that we can make Hadoop network go faster? And the answer was an absolutely yes. So we programmed this OpenFlow network that is connected to the Hadoop cluster, and we gave higher prioritization initially to the Hadoop traffic. When we did that, immediately the performance increased by 20% with our user space code, and it was even pre-alpha. So all of these results were actually published in a paper, and they're all available on flowforwarding.org. So there are additional things that you can actually do in terms of flow prioritization. Then one of the other things that we also did is that we hooked up a small program to the job taskers, if people are familiar with Hadoop, so that dynamically before a job is sent to the nodes, they would send an event information, and we would go program all the nodes so that the traffic and all the other things happened nicely with the right set of prioritization and queue entries. So another problem with having lots of switches and network elements in a network is being able to manage. And OF config is a protocol that allows you to centrally manage a OpenFlow cluster of switches running on a capable switch. So an OpenFlow switch, just to differentiate, an OpenFlow switch is a single instance of a switch. In a capable switch, which is as specified in the OF config specification from ONF, it's actually a container which can actually instantiate multiple OpenFlow switches within the same container. So why is this important? One is resource allocation. So you have a specific set of ports on hardware. Each OpenFlow switch can be a logical switch, and you can associate those ports to those physical ports on the switch. So that is an important concept. Additionally, you can use OF config protocol to configure each one of these OpenFlow switches to talk to specific controllers. So today, I might want to talk to controller, I might want to associate this OpenFlow switch with controller A, and tomorrow, I may want to associate it with controller Y. That is possible with OF config. And normally, the person who is going to operate on these so-called capable switch would be a network administrator, whereas the flows are going to be programmed by an application programmer via the controller. So there are two different actors. So that's another role separation scenario that is enabled by OF config. And Link is the only switch which actually supports OpenFlow capable mode. And so this has been of tremendous interest in the industry as to how one could actually use this. So one of the things that we looked at was, okay, how can we make, how can we start building the fundamental blocks in order to program the network? And here, what we are showing here is the ability to discover multiple OpenFlow switches on the network and also the clients, okay? And also use this as a network monitor, okay? How can we do this? So if you come to our booth, we have a live demonstration of this. And what we are doing here is that all these Raspberry Pis are basically used as Linux clients, okay, that are connected to an OpenFlow switch. And this is a OpenFlow wireless access point. So you have one switch, you have the second switch, and we have the ability to discover these switches not by using LLDP, that is the link layer discovery protocol, which is available on most of the legacy networking switches today, but using flow learning. That means when this OpenFlow client wants to talk to a client here, so it sends out a packet, and there is a processing that happens, and wherein it looks at the source IP addresses, the source Ethernet address, and the destination MAC address and everything. And based on certain rules, it gets forwarded and ultimately to the client somewhere. So this, and because you can actually set up multiple flows on how the topologies are described and everything, so the standard LLDP by itself may not correctly work and how to identify the clients. But with this kind of a flow learning mechanism, one could actually use to discover who is connected to whom at what points in time. And that is one of the ways to discover the entire network. And in our demonstration at the booth, we are also showing as to how simple it is to add flows, wherein not only you can say associate this OpenFlow client with another OpenFlow client by adding flows, but also be able to do network monitoring by simply adding one more entry into the flow modification rule. So where do we go from here? In terms of the roadmap, there has been tremendous interest in the community, and they have been asking for more features. And one of the things that we are actually going to do is that we are already working on identifying what it takes for us to do OpenFlow 1.4. The standard is yet to be published. We are looking into it. And once the standard is published, we will have more information on that. So we want to be as compliant to the latest standard as possible as soon as we can. One of the other things that we are also working on is, because of our work on OF config and the capable switch, we identified several holes in the spec, or there are a lot of things that are not clearly defined. Say, for example, how do you provision certificates into an OpenFlow switch or into an OpenFlow capable switch? So I have started to work on the specification by doing implementations so that we can say what is the best practice or what is the best methodology to do security configuration from an administrator point of view onto these capable switches. Performance is another constant question that is asked of us. And with Intel's help, so we will also do kernel mode libraries as well as DPDK support, so that you really don't have to install any more kernel mode drivers, but you can access all the packets via DPDK. That's the Intel's data plane development kit, where in the packet that comes with the kernel is actually available in the user space. So you don't really have to install extra libraries in the kernel in order to make the packet processing happen. We are aggressively working on supporting more and more and testing on more and more different kinds of hardware. Intel, a whole range of platforms, right from Atom 2, which has 8 cores. And there is the Intel Xeon Pi, which has around 57 to 60 cores and so on, and the Seacliff Trail, and the Tylera, and so many other platforms. Basically, we are experimenting with what does it mean to have more cores and more memory to take advantage of all the flow processing that we can actually do simultaneously. So those are sort of the experiments that we are doing. And I think so far the progress has been phenomenal. In terms of the controller, there is actually a basic controller that comes with the link switch today. Additionally, we have tested this in the ONF's interrupt testing working group, testing it with various plugfests. We have successfully tested it, and we have documented everything on GitHub. And it works with Ryu as well as Ixia controllers. And recently, we also announced availability of a Java-based controller. And this is a Java library that we have developed, which can support either REST, so it can consume REST events and being able to program the switches. It's a 1.3.1, OpenFlow 1.3.1, it has support. As well as it also has a Java API that you can hook it up to your applications so that you can actually perform programming of the OpenFlow network. In terms of testing, there is an open source Twister framework, and the Twister folks have been gracious enough to test their test framework against Link on a weekly basis, and they publish all that information, the test results, and raise bugs, etc. And they're all posted on our mailing list. So this is another methodology wherein all the open source community folks have come together to provide more and more capability to these kinds of efforts. So while we have been doing all of this work, we want to make Link more and more production ready. Many of the vendors, hardware vendors today who are supplying boards and systems, now they have started to put Link on their hardware platforms free of cost so that you can actually do OpenFlow, you can get up to using OpenFlow in a relatively short period of time without having to download more software. So this is a phenomenal capability and an endorsement for the community per se. We thank all the people who have come to support the community per se, and all the other vendors who have started to provide commercial support for people for specific use cases, and also to people like ADI Engineering and many of the Intel vendors and so on, and Tyler, who have started to put their pieces of hardware, and they have taken Link software, which is all Apache 2 licensed and commercially friendly license, and put it on their systems, and then providing it to the developers as a development kit. So that's actually fantastic. And we welcome everybody's help in writing more code and applications to make Link, OpenFlow, and SDN with network white boxes a success and a reality. Thank you very much.